Okay, let's start with the mug first and build it up from here. This will be our container for the liquid, not parented, that's good. I'm going to delete that modifier, check the geometry just in case. Always check the normals should face outside. Let's add an icosphere or any object, this will be the source of the liquid. Apply all transforms, place the origin to the geometry. Then add a quick liquid effect. Resize the domain to around the mug. Domain is the place where the simulation takes place. Out of this box there will be no simulation. Now if I hit play, it just works. Great. Let's add the fluid to the mug and select effector. This will be the collision. Leave it like this and it's going to fall through right now. First I'm going to show you that with the domain selected, you can increase the simulation resolution here. It's working best with the power of 2, so 32, 64, 128, 256. But the higher you go, slower it gets, but it will be more accurate. Here in the timescale you can change the speed of the simulation. Now let's fix that collision issue. So the only thing you have to do is to tick in is planar. Every object that is not a closed object usually will need this option ticked. Let me just switch back to original speed. So this is the first version, which uses geometry setup instead of flow or outflow. This means that the liquid just splashes according to the forces in the scene. In this case only the gravity. There will be no more, no less liquid. Now let me show you a cool thing you can do here. I select the domain and under constraints I add a child of constraint and select the mug. Now if I move the mug, the domain comes with it. Now let's animate the mug with a little movement. And now if I hit play, the liquid stays in the mug properly. If you want to change the material of the liquid, you only have to change the domain material. Grab something from BlenderKit for this duty. Now let's check the more dynamic versions, which is flow and outflow. I will demonstrate this with a tap and a sink. I'm just quickly set up a scene here. Always apply all transforms and set the origins, this is really important. Okay, now I will add an icosphere again and place it just inside the tab. Again, apply all transforms, don't forget that. Let's add the quick effect, then scale down the domain. Now if I hit play, nothing will happen because I need to increase the resolution. This can happen if your object is quite small, so keep this in mind. At the domain, this cube in the corner indicates the size of the simulation grid cell, which will change if you change the resolution division settings. And now it's working as it should. Now if I select the icosphere emitter, we can see that the flow behavior is set to geometry, which is the basic setup for liquid simulations. But now let's change that to inflow. What this will does is that now it's going to constantly emit particles. Now it's good, but it's going through the tap. Let's add a liquid to it and set it to effector. Again, as you can see, it's going through the mesh. It's the same case just like before. Because it's not a closed mesh, we need to tick in planar. And now it's colliding as it should. Next, we should stop the flow once it reaches the train. For that, we are going to use an outflow. Add the cube, for example, place it under the sink. Add the fluid, select flow, change the flow type to liquid, then change the flow behavior to outflow. This button is the on-off switch. So at outflow we want it on all the time. And now you can see that the water is disappearing once it reaches the cube. Any fluid that enters the bounding box of this outflow object will be removed from the domain. This can be useful to prevent the whole domain from filling up from the inflow object. So as I said, this button is an on-off switch for the simulation. Think of it like the lever on the tab. With this you can stop the inflow object from emitting particles. Let's create some example here with some keyframing. So first I want the tab to be turned off, so I'm going to turn off the use flow and keyframe it with I. I'm going to also keyframe the lever. At frame 30 I will rotate it by 90 degrees and key it. Just for a bit more realistic effect, I'm going to jump back to frame 90 instead of 30 and keyframe the flow again. Then jump one frame ahead to frame 20. And here I'm going to enable the flow and keyframe it. I'm going to jump ahead in time and do the whole process backwards to stop the flow again. Now let's hit play. And it just works as I wanted. It kinda looks like the T1000 is coming through the tab, but don't worry, it's just the lightning, the material and the EV. You can always change the material of the domain as I said before, just grab this from BlenderKit. And here's the cycles version. To create oceans, the best way is to use geometry version. Make a larger cube, apply everything, add the liquid, then scale down the emitter object. Set the simulation frame rate to something huge. Add some random stuff, animate it, use collision objects, and you can create stunning things. Mine is not that, but yours can be. If you're creating it from scratch, you need to add the domain fluid theme to your object. Select liquid and add an emitter object. add fluid and select the flow type. Now a few important options. First is under your emitter, under initial velocity. With this value, you can add axis-based force to your flow object. For example, here you can see in the x-axis, if I add 5, then it starts flowing to that direction. Let's invert it to minus. Let's add a little more strength. With this you can do pretty interesting things. Next one is your domain and border collision. With this you can achieve similar effects like an outflow object. Next one is to control your fluid with actual forces. With this you can create some magic or commercial kind of effect easily. Next is delete obstacle. This is useful if you have a hole in the collision object of yours and you don't want to mess around with outflow objects. And it will automatically delete every particle that enters that hole. Next is sampling. This highly determines the smoothness of your liquid since it creates more particles. Here is with 5 and here is with 1. Resolution division, as I mentioned, is the main value you need to scale to receive realistic results. There is 3 presets for extra effects: spray, foam and bubbles, but these are only going to be visible in a high resolution simulation. With these you can lift your animation to the next level. When you add one effect, it creates a secondary particle system here. If you delete it from here, it's going to remove the tick from the domain settings as well. So the spray is when there is a big splash. These particles fly through the air, giving some great realism to the simulation. Works well with any kind of liquid. The foam particles are self-explanatory. These are moving on the surface of the liquid, good for oceans, coffee or soap or similar stuff. The bubbles are the only one that is under the liquid. You can create champagne or bubbly water effects with this. Next is high viscosity solver. This determines how sticky the fluid is. Lower values will give natural movement, while higher values result in a more sticky slime. And the most important settings is the baking. So you definitely want to bake your results. Currently it's on reply mode, which means that the cache will be baked as the simulation is being played in the viewport. So it will render it every time basically. That's why we need to bake it down. For that we need to change this to all. And I recommend creating a separate folder for this bake, other than the original it creates for itself. If you're creating an extremely detailed high-resolution simulation where the division rate is 256 or above, then be prepared for a baking time around a little more than eternity. Depends on your hardware, but it's definitely going to be an extremely time-consuming process. Now with all that in mind, you can create your own fluid simulation easily now. Hope I was able to help. Thank you for watching and see you next time.